All right, in 6.4, we're going to be graphing and shifting the graphs of exponential functions and log functions. Now, when you graph these, one thing about it, we mentioned before, like if you look here, see this graph right here, we talked before about an exponential function. That's what an exponential function looks like. That doesn't show up very well, but that's our exponential function. That's an increasing exponential function. Now, we mentioned before that exponential functions and logarithmic functions are inverses of one another. Because of that, I don't know if you remember we talked about before, if you graph a function and its inverse, they're symmetric across this line y equals x. This line right here is y equals x. So if this is the exponential function, the logarithmic function that goes with it looks like this. If you look at that, can you see that they're symmetric across that line? So like this one goes through 0, 1, the exponential function. So the log function goes through 1, 0. That's if it's an increasing. It works the same way if it's a decreasing. Like here's an exponential function that's decreasing. So a decay function looks like this one right here. Well, if here's our line y equals x again. If you make the reflection of that so that it's symmetric across that line, that is the log function. So that's one way you can do it. If you graph the exponential function, you can just do the reflection across y equals x and get the log function. Now, the same stuff we did before with shifting graphs holds with these. Like here, if there's a negative number, if there's a number in with the x, that goes right or left. You can see this. Let me see if I can make that a little bigger. If you can see that, notice here, you see how there's a -3 up here with the x? Anything with the x is horizontal, so that's right 3, and you always think opposite. So even though it says -3, it's right 3. The reason it's right is because that 3 is up in the exponent with the x. Here, if it was x plus 2, that would be left 2, so you just shift the graph left 2. Now notice the difference here. Here, do you see this plus 5 is not up there with the x. It's out here on its own. Well, if it's out on its own, that means it's vertical. So plus 5 means up 5. -1 means down 1. Then if we put a negative in there, like here, notice there's a negative in with the x. Well, if it's in with the x, that means it's reflected in the y-axis, so it's flipped horizontally. You can say it's symmetric across the y-axis. So if the negative is up on the x, it's flipped horizontally. So all the x's, you just change the sign of all the x's. Here, notice here, the negative is out front, so it's not up with the x. If it's out front, that means it's vertical. So this is reflected across the x-axis, so it's reflected vertically. Then, if there's a number out in front, like here it's multiplied by 3, again that's on the outside, so it's vertical. So here you would say stretched vertically by 3, and you need all 3 of those things, stretched vertically by 3. Here there's a 1/4 out front, so that would be shrunk vertically by 1/4. Again, when it's out front like that, it's always vertical. Now the same thing holds for log equations when we start with those. So like here, see in the parentheses with the x, we have a -4. So that means right 4. If it's in with the x like that, it's left or right, and you always think opposite, so that's right 4. Here it says x plus 7 in the parentheses, so that's left 7. Notice here, the plus 3 is not in the parentheses with the x. It's out here on its own. That means it's vertical. So that plus 3 means up 3. Or here, -1 means down 1. So you just take your graph, your basic graph, and shift it like that. Here, notice there's a negative in with the x. Remember that flips it horizontally. So it's reflected across the y-axis. Here, see the negative is out front. It's not in with the x, so that's vertical. So that's reflected vertically, reflected across the x-axis, or sometimes the term inverted. Here, see that's multiplied by 5 out front. That means it's stretched vertically by 5. you take all the y coordinates and multiply them by 5. Here, there's a 2/3 out front, so that's stretched vertically by 2/3. You multiply all the y coordinates by 2/3. So that's the same stuff we did with all our graphs before. It's the same stuff here. So if we graph these, like here, if I graph this first one, y equals 1/2 to the x. Well, we can plug, to get an idea, we can plug some numbers in there. Like if I plug in 0, I'll get 1/2 to the 0 power. Well, 1/2 to the 0 is 1, so that's the 0.01. If I plug a 1 in there, that's 1/2 to the first power. Well, that's just 1/2. Whoops, sorry. So a 1, 1/2. So at 1, I'm at 1/2. If I plug in 2, that's 1/2 squared. Well, 1/2 squared is 1/4. So at 2, I'm at 1/4. Now, if I plug in some negative ones, like a -1, that's 1/2 to the -1. Remember, a negative exponent means take the reciprocal. Well, the reciprocal of 1/2 is 2. So this means the point -1, 2. Remember, a negative exponent means take the reciprocal, so just flip it over. If I put in a -2, that'd be 1/2 to the -2. So that'd be 1/2 squared, which is 1/4, and then the reciprocal would be 4. So -2, we're up at 4. So that's how we would graph that one. Now for the transformation, it says we have the same thing, 1/2 to the x. Now here it has a -4. So that's on the outside, so it's vertical. So that's down 4. So all we would do is take those points we did and move them all down 4. So this one's at 0, 1. It goes down to 0, -3. 1, 1/2 becomes 1, -3, or -4, or 3.5, sorry. 1 or 2, 1/4 becomes down here. Or here, -1, 2, if I go down 1, 2, 3, 4, is -1, -2. -2, 4, if I go down 4, becomes -2, 0. So that graph looks like this. If you looked at asymptotes, like the original has a horizontal asymptote at y equals 0, because that graph's going to get closer and closer. So the original function has a horizontal asymptote at y equals 0. It has a y-intercept up at 1, and it's decreasing, or it's I'll just put decreasing, or it's a decay function. Now the one we shifted, well, now the horizontal asymptote shifted down 4, so that one has a horizontal asymptote of y equals -4. The y-intercept also went down 4, so it's now -3. It still is a decay function. This next one is e to the x. Well, if we put in 0, e to the 0 is 1. Almost anything to the 0 power is 1. The only one that's not is 0 to the 0. So 0, 1. Well, if we put in 1, that's e to the first. Well, e is 2.718. So at 1, we're about 2.7, so we approximate that. If we put in 2, that'd be e squared. If you do that on your calculator, remember there's an e to the x button down here above the ln. So over here above ln is e to the x, so I would hit second e to the x. So my screen looks like that. I want it squared, so I put in a 2. It says that's 7.389. So about 7.4. So at 2, we're clear up at 7.4. If we put in -1, that's e to the -1. We can do that on our calculator. So again, you hit second e to the x for the exponent. Oops. So second e to the x for the exponent, I put -1. It says it's 0.367, so about 0.4. So at -1, we're 0.4. Well, that's enough to kind of give us our graph there. So there's our graph. It looks like it is increasing. It has a y-intercept at 1, and it has a horizontal asymptote at y equals 0, because it's going to get closer and closer to the x-axis, so it never touches. Well, now, if we look at the transformation, see it says +2, and that's on the, oh, there's two things. Notice we have a +3 with the x, so that's with the x, so that's going to be left 3. Then the 2 is out by itself, so that's vertical, so that's up 2. So we're going to move every point left 3 and up 2. So just do exactly that, like this one here. Left 1, 2, 3, up 2. This one here, left 1, 2, 3, up 2. Or 1, 2, 3, up 2. Or this point here, 1, 2, 3, up 2. So that graph would look like this. Now that one is also increasing. The y-intercept, I don't think it has one. Now here, because we went up 2, the horizontal asymptote is going to go up 2. So it was at 0, now it's at y equals 2. There is a y-intercept, but it'd be too hard to figure here. Okay? Or this next one, 2 to the x. So again, if we plug in numbers, if we plug in 0, well, 2 to the 0 is 1. If we substitute in 1, 2 to the first is 2. If we substitute in 2, 2 squared is 4. If we sub in -1, 2 to the -1, remember, and again, a negative exponent means the reciprocal. So the reciprocal of 2 is 1/2. So -1, 1/2. If we went -2, 2 to the -2, that means the reciprocal of 2 squared. Well, 2 squared is 4. The reciprocal of 4 is 1/4. So that graph looks like this. So again, it's increasing. It has a y-intercept at 1. And here it's going to get closer and closer to the x-axis, so it has a horizontal asymptote at y equals 0. Notice this one, up here in the top, we have a -3 with the x, that means right 3. We have a +1 on the outside, that means up 1. So we're going to take every point, go right 3, up 1. So if we start with this and right 1, 2, 3, up 1. Or this point here, right 1, 2, 3, up 1. 1, 2, 3, up 1. Or this point here, 1, 2, 3, up 1. So that graph's going to look like this. It's still increasing. It's going to have a horizontal asymptote. Since we went up 1, the asymptote goes up from y equals 0, so it's y equals 1. The y-intercept would be hard to figure. It'd be 1 1/8 actually, but you wouldn't need to put it on one like that. All right? So that's doing exponential functions. All right, now let's look at log functions. Now log functions are harder to plug in points. So what I would do first is change it to an exponential. So if we look at this, f of x equals log base 2 of x. Now we did that before. F of x means y. Let's convert that to an exponential. Remember, we start with the base, so the base is 2. The exponent, a log is an exponent, so the exponent is y equals our value, which is x. So that would be that same equation as an exponential. We're going to plug into that, only we're going to plug numbers in for y instead of x, because y is our exponent. So when we plug in points, I'm going to put 0 in for y. Well, x would be 2 to the 0, which is 1. So 1, 0. If I plug in 1, that's going to be 2 to the first. So that's 2, 1. Remember, we're always plugging these in for y on these because it's the exponent. If y is 2, that'd be 2 squared, which is 4. So that's the point 4, 2. If y is negative 1, that'd be 2 to the negative 1, which is 1/2. So 1/2 negative 1. If y was negative 2, that'd be 2 to the negative 2. Remember, that's the reciprocal of 2 squared, so that's 1/4. So 1/4 negative 2. So that graph's going to look like this. So it's increasing. It doesn't have a y-intercept. It does have an x-intercept at 1, 0. Or the x-intercept you could just say is 1. And then it's going to get closer and closer to the y-axis. So this has a vertical asymptote at x equals 0, because that's the y-axis. Now here, if the one we're going to transform, notice it's got a negative 3 out front. That tells us two things. The negative tells us it's reflected vertically, because it's on the outside, and the 3 tells us stretched vertically by 3. Stretched vertically by 3. So we have two things. It's inverted because of that negative, and it's stretched vertically by 3. So the easiest way to think of it is take each of the points and multiply the y-coordinate by negative 3. Here the point is 1, 0. Well, if I multiply 0 by negative 3, it's still 0, so that point stays here. Here, this is the point 2, 1. So if I take that 1 times a negative 3, that becomes 2, negative 3. So 2, negative 3. 2 was 2. If we multiply that by negative 3, at 2 we get negative 6. No, I'm sorry, at 4 we get negative 6, not 2, sorry. Here at 1/2, if we take that times negative 3, we get a positive 3. So 1/2 positive 3. That's enough to see that this graph would look like this. So now it's decreasing, which makes sense because the negative flipped it over, so it turned from increasing to decreasing. It still has an x-intercept at 1, the point 1, 0, and it's going to come up here and get closer and closer to the y-axis, so this has a vertical asymptote of still x equals 0. This one again, we have log base 1/2, which we hate it when the base is a fraction. So let's first convert it to an exponential. So start with the base, which is 1/2. This is a y over here. So a log is an exponent. So our exponent is y equals our value, which is x. So that's what we're going to graph. Again, we're going to plug in numbers for y. Well, if y is 0, 1/2 to the 0 is 1. So 1, 0. If y is 1, 1/2 to the first power is just 1/2. So 1/2, 1. If y is 2, 1/2 squared is 1/4. So 1/4, 2. So you can see we're going to be getting closer and closer to the y-axis again. If we kept going here, let's say we say y is negative 1. Well, that's 1/2 to the negative 1. Remember, the negative means take the reciprocal. The reciprocal of 1/2 is a positive 2. So 2, negative 1. If we say x is negative 2, that'd be 1/2 to the negative 2. So we're going to square 1/2 and get 1/4. The negative means we take the reciprocal, makes it 4. So 4, negative 2. So that graph looks like this. So it's decreasing. So it's a decay function. It has an x-intercept at 1. And it has a vertical asymptote at x equals 0. Now if we do the transform one, it's got two things going on. Here it's got a plus 4 in with the x. So that means left 4. Then it has a 2 out front. So that means stretched vertically by 2. So we're going to go left 4, and then we're going to multiply all the y coordinates by 2. So here we're at 1, 0. If I go left 4, that'd be 1, 2, 3, 4, and stretch vertically by 2. Well, here the y coordinate is 0 times 2 is still 0. Or here 1/2, 1. Well, 1/2, if I go left 4, 1, 2, 3, 4, that'd be a negative 3.5. Now I take 1 times 2 is 2. Or this point here, that's at 2, negative 1. If I go left 4, that takes me to negative 2. Then the y coordinate is negative 1. Negative 1 times 2 is a negative 2. Or this point that's 4, negative 2. Go left 4, puts us at 0. Now the y coordinate is negative 2. Take that times 2 makes it negative 4. So that graph looks like this. Notice it's still decreasing. It has an x-intercept. Since we moved it left 4, it has an x-intercept of negative 3. And it's going to, I didn't draw my drawing very good, it's going to have a vertical asymptote. Since we moved left 4 from x equals 0, that'd be x equals negative 4 to draw vertical asymptote. So that's how you graph those. The trickiest ones are the log ones because you need to convert it to exponential in order to plug in numbers.